All right, good morning. This is going to be your assignment for today to keep on track for the AP exam. So we're going to talk about chi-square test for association independence in this video. There's going to be an assignment that is going to be linked with this video, so make sure you do both the video and the assignment to make sure that you are on track for class tomorrow on Thursday, okay? Chi-square test for association independence, two major things you need to know here. It is used with categorical bivariate data from one sample. So yesterday we talked about the homogeneity test. Homogeneity test has multiple samples, so it has multiple populations that it's talking about. For chi-square test for association, it's one sample from one population. So you're looking at one group of people. So that's one of the major differences between the homogeneity test and the association independence test. This time we're going to have two categorical variables, which is this word bivariate. So bivariate is talking about two variables. So if you have two variables and they're both categorical, we're still going to be able to construct a two-way table, but it's only from one sample instead of multiple samples. We're going to see with this test if we have evidence to say that these variables are associated or if they're not associated, excuse me, can't talk today. So either variables are going to be dependent on one another or they're going to be independent of one another. So that's why we call this the chi-square test for association / independence, because you can phrase the null and the alternative hypotheses either in terms of association or in terms of independence or not. All right, and we're going to see some examples of that on the next slide. So for the first one, if you wanted to put these in terms of association, the null hypothesis would be there not association, or there is not an association, versus the alternative that there is an association. All right, so it's not associated versus there is an association. So they're not related versus they are related. Now, if something has no association, that means that those variables are going to be independent. So if they're not related, those variables are independent. If they are related, that means one depends on the other. So notice that the other set of hypotheses that you could have here are that the two variables are independent versus the two variables are dependent, aka not independent. In terms of how you should phrase these hypotheses, I would go with the stem of the question. So when we do our example for this lesson, I would say read the stem, and that's going to be how you're going to kind of phrase your null and alternative hypothesis. So either an association versus no association versus an association, or if they're independent versus dependent. Other than that, there are no real big other changes from the test for homogeneity. So all the calculator processes, all the ways to find the expected count, all the ways to find the degrees of freedom that we learned yesterday when talking about the test for homogeneity are the same exact things for the test for association independence. The major difference is that we're going from multiple samples that represent multiple populations to a single sample that represents a single population. And instead of talking about one categorical variable, we're talking about two. And we're trying to see if these are associated or not. All right, that's basically the gist of the chi-square test for association. All right, so for our example here, let me move this little recorder over to the bottom here. Is going to be talking about part-time jobs versus having a job during the summer only versus had a part-time job but not only during summer. All right, so we have a simple random sample of 100 high school seniors that was selected from a large school district. The gender for each student was recorded, and each student asked the following questions. First question is, have you ever had a part-time job? And number two, if you answered yes to that question, was your part-time job in the summer only? So notice that we have a two-way table here. And notice that in our two-way table, job experience is one category, all right? So this is going to be basically if you have a part-time job or if you don't, or if it's only during the summer. Okay, so that's not representative of multiple populations. That's a single categorical variable. So you're going to fit into one of those three categories. Also, you're going to see that gender is going to be the category as well. So again, this is only coming from a single sample, and you can actually tell that from reading the question. So at the very top, the first couple words of this prompt say it's a simple random sample, not simple random samples, or multiple random samples, which implies that this is not going to be a homogeneity test. All right. So hopefully you're able to kind of deduce that after I was kind of talking about it. For part A, we're going to, on the grid below, or I guess, yeah, on the grid below, construct a graphical display that represents the association between gender and job experience for the students within your sample. All right, so what we're going to do here is, again, we're talking about categorical variables. We should not be drawing box plots, stem plots, dot plots, or histograms, as those represent quantitative data, numerical data. Here we're talking about qualitative data or categories, so that means that we're going to be constructing probably some sort of bar graph. All right, so for part A, we need to construct bar graphs. Yesterday in class when we did this for homogeneity, we did side-by-side bar graphs, so it's going to be pretty much the same here. All right, instead of talking about the, I think yesterday we broke these up into proportions. Sometimes you can do bar graphs just in terms of the numbers of things. So we're going to let this y-axis here be the number of students. So we're going to let that be the number of students. All right, and I think it's going to be safe to kind of scale by fives here. So we can go up by fives because I think the highest number of students that fit into a category is 31. So I think it's going to be safe if we go up by fives. Do notice that we have 3 different categories here for job experience. You could actually put either category here on this x-axis. So here, this could be gender, or it could be job experience. It does not matter. Just for consistency's sake, I kind of like to put the one with more categories on the bottom. So instead of kind of letting you guys choose, we're going to kind of do this as job experience down here. And in terms of making our bar graphs, we're going to separate the bars into males that fit into that category and females that fit into that category. First up is going to be part-time job, or we can actually just do never. So never part-time job. Second category could be part-time, and this would be summer only. And then the final one there is going to be part-time, and that will be not only during summer. Okay. Let's go ahead and graph this. So for never had a part-time job, I'm looking at this first one here with 21 and 31. So I have 21 males who have never done that and 31 females who have never done that. All right. So let's go ahead and graph that. So looking at this, we go up to about 21. I'm going to create a bar. I'm going to go by 2s here. So I think I have some space there. So that's going to represent males. So if I want to kind of make sure I key this correctly, maybe let that be blue and let this be the males. And then for females, we can make that red or something. Feel free to draw whatever, key whatever, doesn't really matter, just as long as you label. All right, so we have 31 girls here. Sorry about the bells. By the way, on teacher work days, they still run. It's kind of annoying. All right, but that's going to be your first part of your graphical display for this graph or in this problem there. All right, so for the second one, we're going to do part-time job only. So that's what's going to be when we have 15 and 13. So 15 male students had a job only during the summer, a part-time job. So that's going to be here. And then for females, it's 13. So we're going to go a little bit less than that. Probably a little bit lower than what I made there. That's not perfect, but you get the gist. Okay, so that one's going to be red, and the other one's going to be blue. And then finally, 12 and 8 over here for that part-time job, but not only during the summer. So that means it could be year-round. It could be some other kind of seasonal job, etc. But basically, you have it not only during the summer. All right, so that's going to be 12 and then 8. So something that looks like this. So blue for this one, and then red. All right, so that's how you create a graphical display there. So you can kind of see if these are going to be related or not. It seems like a majority of students in the sample have never had a part-time job. So it looks like 52. And you can tell that just by looking at the table of values. I'm looking over here when I'm making these comments here. But we want to see if gender has an effect on this. All right. So is there an association between if you're a male or a female and if you have a job? So we're going to kind of statistically show that within our inference procedure today. But you can kind of take a look at the graphical display here of our sample data, and maybe you can make some suggestions there. All right, so for the next part here, this is going to be just one of the scoring guideline pictures. It's very similar to ours, but we're going to write a few sentences for part B, summarizing what the display in part A reveals about the association between gender and job experience for the students in the sample. Right? So what we're going to do now is write a couple sentences there. So if you need a moment, you can pause the video and make sure that you are copying down what you need to. But we're going to go ahead and continue with writing sentences. So first thing here is that I think it's safe to say that most females do not have a part-time job. And that's going to be kind of seen over here. So we're looking at this piece right there. A lot of females, most females do not have a part-time job, and that's going to be 21 versus 31. So we're going to make a sentence there. So most females do not have a part-time job. All right, so that's going to be one of the first things that we can do there. Also, the reason that we're saying that is because out of the 31, there's only 50 females, I think, right? Or 52. And out of 52, 31 is a majority. So most females from the sample do not have a part-time job. So that's why we're kind of making that statement there. You can even, actually, let's put in parentheses. So 31 out of 52, just to kind of make it even clearer. Let's take a look at the other types of categories there. So notice that the males in both the part-time job during the summer only and the part-time job only during this, or not only during the summer, also is going to be kind of significantly higher, okay? So it's going to be pretty high as well. So we would say maybe like males tend to have part-time jobs. Both during the summer only and during the school year. I think that's safe to say. Also, from our graph there, we were able to kind of deduce there that they're pretty close. I mean, in terms of the females and the males in those, but I mean, those are kind of a couple things there. The other thing I have listed here, I think I kind of just sum that up a little bit. Maybe just trying to see if there is an association. Well, it seems here from like what we've graphed and what we described is that females don't really have a part-time job while males do. And we can kind of almost say it appears there is an association between the two variables. And then I'm going to put in parentheses, females do not have part-time jobs, while males do, from our graph. All right, so that's kind of what we have going on, right? So we don't know if there's statistically significant evidence of this, and that's what we're going to do now. So the test for association really kind of takes some of our skeptical or the ambiguity out of this. So it makes it very, very clear if there is an association or not. All right, so which test of significance should be used to test if there is an association between gender and job experience for the population of high school seniors in the district? That is going to be the chi-square test for association. Notice here that the stem of the question is phrased in terms of if there is an association. All right, so back when I was talking about which set of hypotheses you were to use, that's going to be the set that you want to kind of word that way. So there is an association. So we're going to do the association kind of wording. Is it wrong to do the independence? No, it's not. So either is going to be accepted here, but we're going to kind of be consistent with the stem of the question. All right, so let's go ahead and do our inference test. Starting off with our general statement that we want to test the following hypotheses. At the alpha equals 0.05 significance level, where we have h sub 0 and h sub a. Okay, so if you recall back from the notes earlier, so the HO, the null is going to be there is no association. So we're going to say there is no association between, and I'm going to go back to the phrasing up top. There is no association between gender and job experience. And then the alternative is there is an association. Remember on the AP exam that only one needs to be in context, so I'm just going to leave it there is an association. So there is no association versus there is an association. All right? All right, let's go into the next piece. We need to do our condition checks. So we're going to do condition check. Remember the first, and that's uniform throughout the entire inference, I guess, topics, is randomness. Here we had a simple random sample of 100 high school seniors. Remember only to use SRS if it's actually an SRS. So make sure you read the stem, make sure you know how randomness was met there. And then 2 is when we're going to talk about the large sample size condition. So the large sample size. It is very important that you understand that you need to convey when you check large sample size how you're going about doing that. So here in parentheses we're going to say the expected counts greater than or equal to 5. That's what we're checking for. All right. So very similar to what we did yesterday, we're going to pause on the condition checks and we're going to use our calculator here. I kept this table up there because in your calculator you need to go to the matrix menu and we need to plug in just the inner part. So the inner part here is going to be this data. So remember that we do not use the totals when we use our calculator, we only use the inner parts of that. So go ahead and grab your calculator and I'm going to switch over to my calculator now. And I'm going to show you guys how to type this data in. So remember to do our chi-square test for both homogeneity and association independence, we're going to go to second and then we're going to go to matrix. Okay? And then we need to go over to edit. And then we're going to edit matrix A. So remember it's going to usually be rows by columns. So we have 3 rows. I am not on the little cursor thing. So I'm going to do 3 rows by 2 columns. Right? And that's going to let me type in the value. So I have 21, 31, 15, 13, 12, and 8. All right, at this point, you're ready to go ahead and do the test in your calculator. You just have to make sure you edit matrix A. We're going to go to stat, and we're going to go over the tests, and then we're going to go all the way down until we get to test letter C for chi-square test. Just remember that you do not have to come up with the expected counts. The calculator will do that for you. Remember, there's a little gremlin in the calculator that is nice enough to do all that work for us. Once we type in the observed, we're going to go down to calculate, and that's going to be our chi-square statistic, our p-value, and our degrees of freedom. All right, so we're going to kind of go ahead and skip ahead to do the other parts of the test, and we're going to go back and check the expected counts in just a moment, as we already have this on our calculator. All right, so going back to the slide, remember that we're going to skip ahead to the name of the test. So we have chi-square test for association. Test for independence would also be fine in terms of naming this. So we have our chi-square statistic is going to be the summation of the observed minus the expected counts squared all over your expected counts, which is going to be, what was that, 2.71. So remember that since chi-square distribution is always skewed to the right, we're trying to figure out the probability that our chi-square is going to be that value or something more extreme by chance to figure out the p-value. So what's the probability that by random chance we would see a chi-square statistic of 2.71 or something bigger? That's going to be roughly 0.2579. And when we go ahead and compare that p-value to alpha, we have that 0.2579 to 0.05, and we should know that that's going to be greater. And if we know that's going to be greater, that means we're going to fail to reject. Okay, so we've done a lot of the other parts of the test, but we need to make sure that we are able to rely on these conclusions because we have to make sure those conditions are checked in order to say that our test is kind of valid, all right? So going back to the calculator, remember you can go back to second matrix, and remember we didn't type in anything in the matrix B, but now there is one there. Let's go take a look at that. And that is going to give you your expected counts here. Okay, so your expected counts are going to be these values. So we got to check to see if all of these are greater than or equal to 5. All of them appear to be bigger than 5, so that means that the large sample size condition will be met there. So let's go ahead and write those down. I prefer if you do it in matrix form. So 24.96, 13.44, 9.6, 27.04, 14.56, and 10.4, and all of that is greater than or equal to 5. Therefore, the large sample size condition is met because all those expected counts are greater than or equal to 5. Do recall that if you wanted to find this by hand, like let's say I wanted to find the expected count here, well that's going to be 14.56. Now how do I find that by hand? Remember, to find the expected count there, you're going to take the row total, which is going to be 28, and you're going to times it by the column total, which is 52, and you're going to divide that by the table total, which is going to be 100. So notice if I go back over to my calculator and I do the product of 28, not 25, 28, times 52, and I divide that by 100, you're going to get that 14.56 there. So you can always do this by hand. However, using technology is going to be much quicker and much an easier way to make sure that you get the correct expected counts. Right? Going back over to our test there, we can finish this test out because we know that we have our conditions met, so our inference procedure is pretty valid. So let's go ahead and conclude this. So we would say here, since our p-value is greater than alpha, it's 0.2579 is greater than 0.05, we failed to reject the null hypothesis, or HO. So we failed to reject HO. That means there is not convincing evidence to support there is, I guess I should say that there is an association between job experience and gender. So basically what we were able to conclude there is that there is not a relationship between being a male and if you have a part-time job, or if you're a female and not having one. I know we kind of like suggested that from our graph, but there's not statistically significant evidence of that. It just appears to be that way, which is why statistics is cool, because it delves past certain types of graphs and it really says, do we have enough evidence? And here we don't have enough evidence to conclude that. All right, so that is going to be the chi-square test for association independence. There is going to be an assignment that follows up with this, so please make sure that if you need to rewatch the video, rewind it, slow it down, speed it up, whatever you do, whatever you need to do in order to get what you need out of this, because I'm going to expect that you guys know how to do this when you return back to class. All right, if there's any questions that you have, you know how to reach me. Until tomorrow.